In this question, we are going to generate a phase diagram for benzene. Notice how our temperature is on the x-axis and our pressure is on the y-axis, which is typical for a phase diagram. We're given 3 points of interest. The first is the normal boiling point at 80 degrees Celsius. So what we have to recognize is that the normal boiling point is at 760 millimeters of mercury. So I'll put that point on my diagram. Next is the triple point. That's at 48 millimeters of mercury and 5 degrees Celsius. So there it is on my diagram, followed by the normal melting point at 6 degrees Celsius. Now I can connect my lines and put my information about the phases in. So there are my lines. Now for any phase diagram, the high temperature and low pressure material will always be gas. And the low temperature and high pressure area will always be solid, which leaves us with liquid in the middle. Our next part B asks if sublimation is possible at 60 millimeters of mercury. Sublimation is when a material goes directly from solid to gas phase. So I've attempted to draw a line across at 60 millimeters of mercury, and as you can see, that line is above my triple point at 48 millimeters of mercury, so there's no way I can get directly from solid to gas without passing through the liquid. So my answer to that is no. I would next like to know, is boiling possible at 30 millimeters of mercury? Boiling will be liquid to gas, and as you can see when I draw the green line, it is below the triple point. So I cannot get to liquid phase. If I can't get to liquid phase, then I certainly can't do boiling. So I'm below the triple point, and the answer to that is also no. Our next question wants to know, what state will benzene be in if the pressure is decreased from 1 atmosphere to 0.5 atmospheres at 80 degrees Celsius? And as you can see, if we drop down from 1 atmosphere to 0.5 atmospheres at 80 degrees Celsius, we are in the region for gas. Our next question asks, what state will benzene be in if the pressure is decreased from 1 atmosphere to 0.5 atmospheres at 6 degrees Celsius? So what I'd like to do is just expand the temperature range from 5 to 6 degrees Celsius so we can see that the line between the solid and the liquid phase tips to our right. Therefore, if at 6 degrees we reduce the pressure to 1/2 of its value, we are going to be in the liquid phase. And if we start out at 48 millimeters and 5 degrees Celsius and increase the pressure a little bit, we are still going to be in the solid phase. Which brings us to the last question, which wants to know which is more dense, solid, liquid, or gaseous benzene? Well, of course, it's almost never the gaseous phase, so we should look at which one is adopted at high pressure. And we can see that our high pressure phase is solid. The material is more likely to be solid than liquid at high pressure. Water, of course, is completely different. Water's line tips to the left. So the liquid phase for water is more dense.